Okay, wait. I am back. Sorry about that. Just had to move. My parents just got back home, and I did not want to be in the middle of the house. So I moved up to my bedroom here. Okay, let's see if we're live. Oh, we are. Okay. If you want the recap of what I just covered of what the planner does, I got it in the last video, which you can see in the live stream tab over here. Okay. Where was I? Yes. So I got unit movement working. I got it working in conjunction. You know, you can have like put up some mountains, block up some more. I forgot to turn off units. Oh, that's embarrassing. I always do that. But you could have it so like all these tiles are blocked. You know, you can select this guy and move. Let me just get him out of the way here. So you can have this, right? Blocks it all. The enemy units block stuff. It's cool. It works. And it's all relatively optimized. Could be optimized more, but I don't want to do all the math. So now I'm at the point where the last really hard part of code that I'm going to have to do is to code roads. And it's going to be especially tricky just kind of due to how like I implemented movement in the first place. First of all, I want to see if I can get chat to show up on the top of my screen. Is that possible? Program? No. Let's go to OBS settings. Settings. Theme. Video. Hotkeys. It's like if I minimize this, it'll get rid of that tab, which I don't. Do we got any OBS pros in chat? Because I do not know how to layer these things. Update channel. Yummy. Videos. Stream. Output. Audio. General. Wait, I think this might be it. No. Make OBS chat on top. Go to the view menu. Wait. OBS studio window, always the top. Go to OBS. Cancel. I don't see a view menu. Don't mess with audio. Why is it the Doomer guy? Oh my god. Open OBS Studio, navigate to the view menu in the top left corner of OBS Studio. Oh my god, it's here. Okay, wait. Always on top. Cool. So now if I click on here, it's still on top. Now I get rid of dock toolbar. Wait, I get rid of I think, let me just put this in the corner where nobody will ever see it again. No? You'll go there. Test. Okay, cool. You'll go down there. I have chat up here. So now I can code, and if anybody joins chat and wants to... Let me actually check that chat's working. Live. You'll go there. Don't need echoes, please. Do a little test. Test. Cool. I lost my one viewer. No. Whatever. So anyways, kind of go over the code. Everything is kind of hosted by, everything's kind of controlled by this massive, like one singular script. Like we got like the Godot standard like 2D for like the UI and stuff. Like all like the visual representation is all controlled by this double matrix that I list as tiles. So we have this variable tiles. It's a double array. And within this array, we fill it up with two tile dot objects. If we go over to tile, The tile.object contains most importantly, the type of tile it is. So that'll be stuff like, is it like a forest? Is it a farm? Is it a mountain? Not if it's a farm. If it's a field, if it's a forest, if it's a mountain. Later, it would also contain if it's water or not. It'll contain what tribe it has. Haven't actually implemented tribes into the game, into the planner yet, but we'll get there. Probably in another video, because roads are pretty difficult. It'll have the position, so that's like the XY data of whatever tile it is. And then it holds a bunch of other stuff that we'll get into later, like for road, if like the tile holds a road. Spacer, we'll get into what spacer does. Control if it has a unit that's set to positive. What do we set it to? When we press the unit button, update unit, we just set it to type warrior. Cool. Nothing too crazy. And then what we do is we generate a double matrix according to, just like I'm in a for loop, according to the grid size. So if it's an 11, generate an 11 by 11 double matrix. And we just set each one by default to fields of the XY value that we plug in through the for loop. Nothing too crazy. Then we just got, let's see here. We grab like the constant position. This is like pretty standard Godot stuff. If you've looked around, you can find tutorials on this. I think this is like all directly taken from a tutorial. Anyways, yeah, we just have like the button set. It's like when you click on something, it activates a switch case where it sets the tile type and sets the tile.resource. And when you click again, it'll set the tile to, it'll set its zone control first of all. So if it's like a forest, it'll set its zone control to 1. Or if it's a mountain, it'll set its zone control to 1. Otherwise, it'll set it to 0. And then that'll just allow it to, that'll allow the unit to see whether or not like it can move through some tiles. So yeah. Finally, it goes, we go to draw possible unit moves. So this is like when we have a whole bunch of code here. I don't even remember how this all works. I probably should look back into it right now. I'm kind of sleepy right now, and I kind of just want to work on roads. And so I'll kind of get to where we are right now. We have this monster. I actually need a notepad. I need a notebook. Let me open up Paint and kind of show how this works. So basically the gist is, right, I have this huge square grid, right? Where we have all these tiles in it, right? And I have in the center, it's not working. I have in the center sort of our origin point, right? Just make it a little bit cleaner. This looks terrible, right? So we have our origin point, and that's whenever we click and we're in play mode. Let me just paint bucket fill. Like when we click and we're in paint bucket, we have this origin point. Basically, what we'll do is we scan around the origin point with a for loop that is set to 3 and another for loop that's set to 3. Basically, what it'll do is we take the initial vector data. So if this is 0, 0, right, up here, let me get something a little bit bigger. Right, we have 0, 0. And then this is 0, 1. And then this would be 1, 0. And so then we have 1, 1. And then right here would be a 2, 2, right? And so let's say our mouse is hovering over 2, 2. There's a unit there and we click it, right? It'll open up this, right? And what it'll do is it'll pass to it the vector hold pass, which is just tile.position that we set earlier. And essentially, it'll send tile.pass into here. This movement comes into play later, because we actually, this is evil. This is an evil piece of code. Anybody who actually reads this will be like, what are you doing? Who understands coding? It just recurses on itself to like go down the entire list of all possible moves. It's kind of sloppy. It works. It's efficient. It works. It's efficient enough to run instantly at like 8 units. So 8 moves. So anyways, basically just going to break it through. First of all, it'll check if movement's greater than 0. We'll get into why we'll do that later. And it'll also set whatever, it'll set the tile map. We have this tile map, right, that expands over the entire, like, this is like part of Godot. It's pretty nice. It'll create the basis of where we place our tiles. And on it, we have these free tiles, zone of control tiles, and zone of control source tiles. That's what you saw when I was like playing the program, right? And you can see like when we place it, right? What it'll do is it'll initially start whatever tile we're hovering on when we click on them, right? It'll set that as tile.position. It'll set that tile to blue. Okay, so it sets it to blue here. Don't gotta worry about movement just about yet. And then for X in range 3, for Y in range 3, so go 0, 1, 2, pretty much. It'll create a new variable called vector hold. And vector hold holds it's like the initial coordinate that we have. So it'll be 0, 0 is what vector hold's equal to. So I'll write it up here. We have vec hold set equal to 0, 0. Well, in this case, we're clicking on tile 2, 2. So I'm going to erase this. It'll be set to 2, 2. Plus a vector of X and Y. When we run through the for loop initially, X and Y will both be 0. So it'll be plus 0, 0. 2, 2 plus 0, 2, 0 will still equal 2, 2. And then we subtract it by 1. Which will basically mean that, it does mean that vec hold will get set equal to tile 2, 2. Or in other words, this slot right here. And so using this sort of method, right, as the for loop goes down, right, the next xy would be 0, 1. So it'd become 2, 3, minus 1, minus 1. It'd become, well, actually, this is 1, 1, not 2, 2. Sorry about that. So basically when we for loop it, right, this is the first loop, right, it'll be 0, 0. The second loop will be 0, 1. Actually, I think it'd be 1, 0. No, it'd be 0, 1 because it goes through all of the y for loop next. Right? And so now what it'll do is y is equal to 1. It'll become, our vec hold will become equal in the second loop to 1, 2, which will access, of course, this tile right here on the second run. But we got a lot more that happens before this, because first we need to check a whole bunch of data, right? Basically, first of all, we need to check, is this coordinate in bounds, right? Because if our initial tile we selected was like, something like 3, 0 down here, then it would try to select 3, -1. Which actually causes my program to crash because it's out of bounds. It's not part of the matrix. So we can't have that. So I just run a little thing called vector hold in bounds. It'll make sure that very basic function. It basically just takes whatever is plugged into it, and then if it's not in bounds, it'll return false. If it is in bound, it'll return true. So you just plug that into an if statement, and that'll actually give us what we're looking for. So this checks if it's in bounds. And then first of all, we check, is this like a forest or something that's going to limit movement? If the answer is yes, we set the cell equal to yellow. Else, if it's an enemy unit, we just set it equal to a random variable. This variable doesn't do anything. I just don't want to run pass because I think pass might do something. I don't know. I'm not good at programming. Anyways, basically what I'm trying to do here is I'm trying to make sure if it's like a forest or a enemy unit, we don't overwrite what is on that. We just set arbitrary values. And then if it's not that, we can kind of go even further down the loop, right? And so basically we run another for loop of range 3, which is going to do exactly what our current for loop does, right? Our current for loop will eventually check this tile, it'll check this tile, it'll check this tile, and then it'll go down. It'll check this tile, it'll check this tile, it'll check this tile, it'll go down. It'll check this tile, check this tile, check this tile, kind of in a 3x3 grid. So the second for loop does the same exact thing, only it's on the first selected tile, right? So now it'll access the next tile over. So in this case, it'll be over here as 0, 0. So we'll just set it as pink. So this is the next tile that it checks. And what it will do is it wants to see if it's an enemy unit. Because if it's an enemy unit, it actually has to set this tile as a tile that's affected by zone of control. So yeah, for I of range 3, for J of range 3, we'll have vechold 2, vechold. Basically, we're just doing the same exact thing as I did over here, right? So I'll check all that data. And then if this second, right, so if this tile that we just accessed, which we said is vechold 2 is the tile we accessed, vechold 1 is the blue tile, right? If this tile has an enemy unit, right, for this example, let's just say it does, right? There's an enemy unit here. It'll say, okay, what we need to do is we're going to set vector hold, right? Remember, vector hold is equal to this tile here. Vechold 2 is equal to this one. We'll set vector hold equal to a yellow tile in the tile map, right? So this will become yellow. And we'll set our original tile up here equal to red, right? So we found an enemy unit. This becomes red. And after that, we don't do any recursion, right? We'll go to this next if statement. So we do still have to pass through some more stuff before we're out of next tiles too. After it runs the for loop, it'll check if the original tile that we accessed, so in this case, it would be 1, 1. We check if it's yellow or red, or if it's not yellow or red, right? And we'll actually see that it is yellow, which I believe in my tile map is 12, right? It'll see the ID 12. That will mean that this value will return false, which means we don't run this if statement, which means we don't recurse any amount. And so now for our second example, I'll show what happens when it does meet that criteria. So now that we finish this, it'll go back to this initial for loop, and it'll access the next tile over, right? Because x is still 0, y becomes 1. So it'll access the next tile over, which is, let me grab my little stencil here, 1, 2. So it'll access 1, 2. And then it'll not see that 1 tile 2 is a forest or anything, or an enemy unit. Let's just pretend that it's a field. It will set I in range 3, J in range 3. Basically what it's going to do is it's going to check kind of the same way how I checked over here. So I'll check this tile here, 0, 1. And it will not see any enemy units on it. And it will go, that's cool, nothing happens. Next, it'll check 0, 1, or 0, 2. Not see any enemy units. It'll check 0, 3, not see any enemy units. It'll check 1, 1. Though 1, 1 is yellow, it is not an enemy unit source, so it won't see anything. It'll check itself. It won't see anything, obviously. It'll check 1, 3, won't see anything. It'll check 2, 1, won't see anything. 2, 2, it'll check 2, 3, won't see anything. So it goes, okay, it's not going to change its data to anything. Finally, we run to this source. It'll see that it's not of ID 12. It'll see that it's not an enemy unit ID. And so finally, it'll check if its movement is greater than tiles vector hold x, vector hold y, movement distance. What is movement distance? It's a completely different variable, which by default I set equal to -1. So every tile has a default movement distance of -1. So I'm going to put this over here, right? Every tile has a default move dist. If this is a little confusing, confuses me too. This is kind of the best way I can explain it. Move distance by default is set equal to -1. It'll check if movement is greater than movement distance. In this case, the movement we pass is equal to the movement of the unit, which is 2, it'll see that 2 is greater than -1. So it'll actually let us recurse. And what this does is basically, before when I was running this program, and I just let it run, it would have to check every single individual square, and then it check all the nearby squares, and it kept checking like squares that have already been checked in the past, with pathways that are less efficient than the ones we already had, which we don't need to check. So I needed a variable to kind of prevent that from happening. And this is what move distance does. So we set the move distance of this tile equal to 2. And then finally, what will happen is we will run next tiles 2 again. We'll recurse it. We'll pass the movement data. So movement data at this point is, well, actually it'd be 1 because we passed it originally, but the movement set equal to movement minus 1. So we send in 2, 2 becomes 1. We send in 1, and then we send in the data of this tile here, right? And so now we recurse. And when we recurse, vector hold becomes vector hold passed. Movement goes from 1 equal to 0. Then we set the cell equal to blue. So this cell becomes blue. And if movement is greater or equal to 0, it is equal to 0. It'll run the program. And basically, from this point onwards, we repeat the exact same process. It'll check the next tile over. It will check all around it, and it'll actually see on this tile, right? It'll access this tile, see that there's nothing there, so it won't even go, because that's not how it'll tile check. Inbounds will prevent that from happening, right? So see this, out of bounds, see this, out of bounds, see this, out of bounds, see this, nothing here. We'll actually see this next, right? And then it'll be like, oh, there's an enemy here. I set myself equal to yellow. Yeah, and then once that's set equal to yellow, does it actually check the rest of it? Let me think here. I need a cup of water. My throat is hurting. So set it equal to yellow, and then running through the rest of the code. It will actually run through the rest of the code. So I'll check all the other tiles around it, see nothing there, and it'll be like, okay, I'm yellow. Next, this program will check this tile, and this tile will not determine any enemies. And so like before, it'll run through all of this. It'll run through all of this, see that there's no enemies around it. Finally, it'll see that it's not yellow. It'll see that it's not red. It'll set its movement distance equal to 0 at this time. Also, this movement distance would have been equal to 1. It'll set its movement distance equal to 0. And it'll set itself equal to blue. And so this is basically just how my grid will initially detect, oh, I got a unit up here. It'll check all around it, and it'll be like, okay, I got 2 movement. It sees an enemy here, it sets these tiles to yellow, sees everything else, sets it to blue. That's movement done. It's relatively efficient. Like when you're running like knife distance, it does end up checking like 6,000 times. So if we just set like our unit graph equal to 6, right? It works instantly, right? It loops around 870. Actually, I don't know if it loops around 870 times. I used to have a way to check that. I removed it though. You just print looped, and then let me get rid of my other debug code. Get rid of you, get rid of you. Oh, and I guess it'll check. Does it check next tiles again? It does check next tiles again. Expect indent for 4 block. Oh, because I got rid of all the testers. This 4 block is simply for debugging. So I'll comment out this. Code should still work without that. Yep, and so it runs 887 times. It runs 887 recursions. It runs 887 recursions where like it's actually recursing over the next time. But if we actually remove this movement distance thing, which makes sure that we don't arbitrarily recurse, right? If we find an inefficient pathway compared to another pathway we've already found, Let me try to run this program. You'll see it actually takes a while. And at 6 layers of movement, instead of just taking 6,000 ways, we'll still get the correct answer, right? But because it checked every single possible combination, it'll run 38,000 times, which takes quite a while to run, as opposed to bleh. Just like a simple 993. I guess it'd be over here. 1,000, 1,000. Well, actually, not this. Let me clear first of all. Click off. Click on. It only runs 918 as opposed to 98,000 or 38,000 or whatever. Live chat. All messages are visible. Do we have anybody watching, or am I just talking to myself? I do have somebody watching. Yay! Hello, singular viewer. I'm so glad to have you today, so you can hear my insane rambles. This is great. This makes me so happy. So that's how unit movement works. Hey, it's Bluebug. Hello. Now we got to get to roads. Let me go grab my notebook. I'm gonna try not to dox myself. I'm gonna go grab my notebook because I'm gonna show you the theory. I haven't gotten roads implemented, right? But I have my theories on how to get roads implemented, and it's a bit wacky. I'll let you feast your eyes on the code while I go grab my notebook of my theory of how to make this work, and then the rest of the stream for today will just be me trying to get roads to work. So I'll be right back here. I am back. I'm not particularly good at coding, but I understood your explanation. W! That's all I need to know. Because if you can understand it, that means anybody can understand it. And that's kind of the point of a devlog. I'm hoping somebody down the line will be like, oh, I can actually use this. This is pretty simple. Speaking of being able to use this, I should actually link all of the code. Because I have all the code public. This is open source for right now. I might make it closed source later, but like right now, all this code is like kind of just stuff I've learned from other people. So it's like it just makes sense to make it all public. So we go to here, edit video, and I'll just throw in the GitHub link. Hopefully YouTube will actually let me post the GitHub link. Voila. And if I just go here, yeah, GitHub link works fine. Open source, I know, right? Open source will set us free. That's what I'm saying. Okay, let me drink some water here, because my throat is so sore if we're talking for an hour. Okay. Because I've only got this one in theory. I'll show it off. Sweet, glad the link works. Try not to dox myself here, though. Voila. Wait, that's the wrong. OBS is down here. Okay, let me grab my pen. Video capture. All right, cool. So I've got this basic. Let me get this. This is a terrible way to show it off. Yes, stay hydrated, King. Amen. Hydration. Dehydration is dehydration. We don't dehydrate here. Okay, so here is my general. Oh my god, everything's mirrored. It's all mirrored. Oh, it's all going to terrible. Wait, no, it's not mirrored. This is perfect. Okay, basically, here's the theory of how roads are going to work. I create a. We go basically we want to go twice as far as where movement is, right? So if we have a 3 movement troop, we want to go 6 blocks away from source. Source being right here, right? So if we have a 3 movement troop, like a knight, for example, and we wanted to move, if we want to see if it can check roads, we want to check all tiles that are 6 tiles away, that are within 6 blocks away, double its movement of 3. So what we do is we basically, where this is our source, everything around the source becomes 5, everything outside of there becomes 4, then 3, then 2, all the way to 0. And so what we're going to do from here is we're going to check if a tile, if 2 tiles bordering each other have roads. And what we can do is if one tile, oh my god, this is so hot. It's the middle of summer and I'm wearing like, I'm wearing flannel and a ski mask. I'm being cooked. Anyways, what we're going to do is we're going to check if the original tile has a higher movement distance than the second tile. So, for example, right, it'll check, if it's checking this tile, right, it's going to check all the tiles around it. And if it finds a tile that is of movement distance 4, what it will do is it'll set its spacer value equal to 0. And if it cannot find a tile that has a movement of 4, so if like it finds a tile that has a movement of 5, it won't bother, because that's like moving from one distance to the same distance, which doesn't really matter for calculating movement. Although it will matter later, I'll get into it later. Anyways, so basically what we're going to do is, I've basically already done everything I need to show you here. Let me bring it back here. I need to take off this mask, bro. I'm being cooked alive! Basically, okay, wait, OBS is on top. Basically, we have our secondary. Let me expand this out more. OBS, you're in the corner. Basically, we got our second grid. everything's labeled 6 and so and whatnot. And what the idea is that we assign to tiles a value called spacer. And what spacer is going to do is, if spacer is set equal to 1, the next time that the troop moves on it, it'll remove movement by 1. By default, spacer is set equal to 0. And basically, or by default, we set everything around the tile equal to 1. And then what we do is, now that we have, like, let's say it's a 2 troop, let's say it's a 1 movement unit, right? Everything here will be set equal to times 2 minus 1. So it'd be set equal to 1, 1, 1, 1, 1, 1, 1, 1, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. And then let's say we have roads. We're going to do this at an underlayer so I can actually demonstrate this. Let's say we have roads from like the starting city going like so. So these 3 tiles have got roads, and then like this tile has a road, but it's separated. What we're going to do is, anytime that we find a road anytime we find a road in the graph, right? If its movement distance is greater than the movement distance of a bordering tile with a road. So for example, this is one tile, right? This is one tile, right? If its movement distance is greater than a bordering tile with a road, it'll set the spacer on the bordering tile equal to 0. So red will be equal to 0. And then same thing would happen here, right? We'll check this tile. We'll see that this tile by default is set equal to 2, not 1, because this is the source tile, right? And it'll see that 2 is greater than 1, and so it'll set the spacer on this tile equal to 0. Everything else has a spacer value of 1. So everything without a road on it, or without a bordering road that changed its road value, will be set equal to 1. And the theory is that now we just run our movement code that we ran back here, only we run it twice as deep. So instead of running 2 times deep, we instead run 4 times deep. And so now when we run it though, we'll have spacers involved. And so spacers basically take whatever movement is passed into it at that given moment, and it will set its value down if there's a spacer value of 1, right? Well, actually I set it to -1 in my actual thing, and then I just add spacers, which I probably should do it the other way around, but I need more. My throat's giving up. I already drank all my water. Are you kidding me? Whatever. All right. That is the basic idea of how spacers are going to work. Don't know if they are going to work. So we're going to get working on that for today. God, have I already been streaming for 30 minutes? For 40, for 50? I've already been streaming for an hour. Jeez Louise. Ram Dingler upload! Let's go! I love Ram Dingler. Favorite polytuber out there right now. Oh, there goes my laptop stand, which is just a folder full of paper so my laptop doesn't overheat on my bed. Okay. Ooh. We got 3 simultaneous viewers. This is awesome. If you're lost at all, you're going to be lost if you don't check the rest of it. Otherwise, if you just want to see me code, because I just about finished the explanations, but if you want to see me code, feel free to tune in. Otherwise, I'd recommend checking out everything else where I kind of explain all the backbone of what I'm covering. So anyways, that's the general theory of spacers. So if we have a road connected to another road, and the base road has a higher move distance value, it will set the second road with the lower move value spacer to 0. And so when we run the code at twice the movement value, for each spacer, it'll set the movement down by 1. And hopefully that'll allow us to run some roads. I have noticed some bugs on just paper, which is no good. But for what I'm doing right now, it's a good start to getting roads done. So now it's time to actually get hopping into code. So here's where I'm currently with roads. I'm going to set the unit movement equal to 2 instead of 6. And I think that should be, let me remove enemy units because we're not talking about enemy units right now. We're just trying to figure out roads. So we're going to remove enemy units. This function right here, tiles.00, tiles.11, tiles.22, tiles.33 are equal to roads is set equal to true. That'll basically set those tiles equal to roads. I haven't actually implemented any visual aspect of roads, but that will, in the same effect, set, I don't really want to create another graph, but just pretend that like if this is 1, 1, this is 0, 0, this is 1, 1, this is 2, 2, this is 3, 3, and I'll kind of show you on. I could just show you it. I don't need to talk it through. Basically, this tile coordinate here is 0, 0. This tile coordinate is 1, 1, 2, 2, 3, 3, 4, 4. Those are all equal to roads. And so when here's where I am so far. It doesn't work. So I'm trying to figure out why it doesn't work, because in paper it should work. Oh, I know why it's not working. I'm not even recasting next tiles 2 as a double movement. So first of all, let me run that, because theoretically I don't even need to run this first, but I haven't gotten rid of it because it hasn't. I don't want any unintended errors while I'm just programming this. Still doesn't work, still doesn't see the roads. So what is going on here? I think the current issue right now is that I'm setting move distance equal to 5, which when we try to run the code, it'll actually get blocked by road tiles 2. Not road tiles 2, so it'll get blocked by tiles 2 because it won't recurse unless if it sees that the bordering tiles are equal to something. So what I'm going to do instead is, instead of setting it equal to this difference function that I'm using on road.tiles, I'm going to set it equal to, I want to keep this for later, so I'll write this in a comment. But for now, I'll just set it back equal to default, -1, and see if that gives me any difference. And I'll still set the spacers equal to whatever the spacers were. Although this might run into some issues on my second road handler. Yeah, it will actually set some issues. So we're still going to set it equal to the movement distance variable. But then, once we get outside of this, I actually have this function to reset move distance equal to 1. So I'm going to uncomment it out. So this sets move distance back to default. And now we're going to run our secondary movement. So it'll do the roads. It'll get all the road data that we need. I'll set our initial tile to that. I think this should work. So we do actually see some increasement in movement, which is progress, but it's not the progress that I'm exactly looking for, because let's see here. It goes 1, 2, 3, 4. Oh, wait, this actually might be. This is better than I thought it would be. And then if you see here, we're actually off a road. And then it should go 1 and then gain road access again, which it's not doing. So let's see if I can find out what is causing that. Actually, before I do any of that, I'm going to get another cup of water because my throat is very sore from talking for an hour straight. So I will be right back with you. actually have the kettle all ready to go. Look at me go. Don't gotta spend a whole 10 minutes brewing water. And if you guys have any questions about, hi, what you building? Hello, I am building a turn planner for Polychamps. I kind of gotten into it a lot more detail earlier in the live stream, so if you want to see all kind of like the nitty gritty of what I've been talking about, totally feel free to go back there and watch it all. As of right now, I'll just kind of give you the basics. I'm basically recoding Polytopia from the ground up so I can plan turns in Polychamps easier because MS Paint is a total pain in the butt. And right now I am working on, I have the basics of unit movement done. Right now I'm just trying to get roads to work. And yeah, I'm basically just I'm trying to have these live streams up so that it's all documented. So if people ever want to like figure out how I coded it, they can go and do it for their own projects and whatnot. So if you see when we're on a road tile, right, it is seeing, right, that this tile's a road, this tile's a road, this tile's a road, this tile's a road, right? So we'll see that it can move here, and then it still has one more movement. It can move here. It can move here and here. It's actually working perfectly. When we're right on this spot, it is actually working. Roads are working perfectly, which is kind of cool to see. We move back here. It can move like 1, 2. Well, it can move like 1, it can move like 2, it can move like 1, it can move like 2, it can move like 1, it can move like 2, it can move like 1, it can move like 2. Roads are actually working perfectly here. If we go here, it can move 1, and it should be able to move again. Which leads me to believe, I wonder why that is. Because here it works fine. Here it works fine. Here it should not be, because this is 0, 0, 1, 1, 2, 2, 3, 3, 4, 4. So it goes 1, 2, 1, 2, 1, 2. These are all legal moves, I believe. I should get a road graphics I should get a road graphics implemented because it's a little hard to debug right now. But then if you see when it goes upwards, it's actually not, we should be able to move to this tile. And by an extension, a lot of these tiles over here. So what I'm going to do is I'm going to have to do some debugging with my debugger tool here. Oh, we're not setting spacers back to default, are we? That might be the issue. No, we do set spacers back to default. Okay, that's cool. Well, I do actually want to check that. So let me go down to 4, 4. 0, 0, 1, 1, 2, 2, 3, 3, 4, 4. We do have 4, 4 set to a road, yeah? We do have 4, 4 set to a road. This is a little troubling. So I'm going to run my debugger, which should be right here. We're going to print position, we're going to print spacer, and then we're going to print movement distance. Actually, I don't care about movement distance because we reset it. I don't know if we reset it. We're going to get rid of the pass statement. So I'm just going to run it up here. Unit, nope, you're in the wrong spot. So when you run it at 4, 4, first of all, I need to get through all these loop statements. So let's see what 4, 4 is at. So 4, 4 is set to 0. 4, 4 does not have a spacer, which is a good thing. 4, 3, no, wait, 3, 3 shouldn't have a spacer either. 3, 3 should be equal to 0. 3, 3 is equal to 0. 2, 2 should be equal to 0. 2, 2 is equal to 0. 1, 1 should be equal to 0. 1, 1 is equal to 0. 0, 0 should be equal to 0. 0, 0 is equal to -1. Actually, let me check. Let me consult my graph here. 4, 4, right? 1, 2, 3, 4. Actually, we don't even need to care about 0, 0 because that's far enough away. So I think it's far enough away that it doesn't matter. So that's good. It means our spacers are working, which means the error must be with movement not working, which worries me a little bit that would be causing an issue, because I have an idea of a patch fix that might work, right? Like if spacer is... First of all, I'm going to set spacers equal to 1, and I'm going to set these equal to -1, and that might... No, I don't need to do that. What I'm going to do... what do I do? Because the spacers are working as intended. Let me bring back... I want to see what's happening with the movement distance counters, because that might be causing the error. So I'm going to go to here, movement distance. We're going to comment out spacers. And I'll just see if this works. So we start at 4, 4, 0, 0, 1, 1, 2, 2, 3, 3, 4, 4. Another thing is I want to get rid of this loop statement because I'm not using it right now. 0, 0, 1, 1, 2, 2, 3, 3, 4, 4. Boom. So we'll see that... What's setting 4, 4 equal to 0? There shouldn't be anything setting 4, 4 equal to 0. I'm happy that it's setting it equal to 0. So I see that 4, 4 is set equal to 4, which is our base move case. That's good. 4, 5 is set equal to 3. 4, 5 should be set equal to 2. No, because we haven't even run the second. I actually want to be checking these after I run next tiles too. So let me actually do that real quick. And then another thing I want to do is actually need to change this XY. I need to change this XY range because the formula is wrong. I actually had to do a bunch of math to figure out my formula was wrong. I was so confused for a while. So grab movement. It's actually movement times 2 plus 1 instead of movement times 3. That'll get me exactly where I want to be. So I go to my new print statement that I just pasted in. Should be right here. I think I accidentally pasted the wrong formula. I don't want you. I actually want you. And I just want to check anything. I don't want any unnecessary data. I just want to see what we would be affecting, which is just this. So go over to this print statement, and we're going to paste in the range we provided here. And we don't have a closing bracket. Ew. Or we have too many brackets. Okay. Movement times 2 plus 1. And then we actually want to times movement again because we're going twice as far instead of what movement is. Times 2. And start. So now when we run at 4, 4, 0, 0, 1, 1, 2, 2, 3, 3, 4, 4. And now that we check it, we'll actually only get data that we want to use. So at 4, 4, after we pass through it a second time, set equal to 3. That makes sense. So let me open up MS Paint here so I can calculate some stuff. Normally I just do this on paper, but since I've got 1 watcher, 2 watchers, let's go. 1 watcher, wait, no, because I'm 1 watcher. So 2 watchers, let's go. Thank you guys for watching this. Hope you're enjoying my really boring technical madness. So set equal, our base tile is set, this needs to be larger. And I also need a little matrix. So we have our base tile. We'll set this here. It's set equal to 3, and every tile around it should also be set equal to 3. I believe. So we have 4, 4. 4, 5 should also be 3. 4, 3 is 3. So 4, 5 is actually going to be over here. And 4, 3 is equal to 3. I'll just mark you as like orange to make sure that I know that this is my base tile. And then so should all of these around it. Those should also be 3. So if I go to, I need to go to 3. 3, 3 is equal to 3. 3, 4 is equal to 3. 3, 5 is equal to 3. So there's my confirmation. All these are equal to 3. 3, 3, 3. And then these should be 4. Should be 4, 3. 4, 4. Or actually, it should be 5. 5, 3 should be 3. 5, 4 should be 3. 5, 5 should be 3. So movement distance is working as intended so far. I'm going to need more matrices. Just expand it all out. And all these other tiles should be equal to 2. I wish I could just print this as a matrix. I probably could just print this as a matrix, but that would require me doing a minimum amount of effort. Oh, but it would save me so much time in debugging. I should just print something that does that. Whatever. This function shouldn't be used. Yeah, I commented that out. So we go to something like 3, 2. Yeah, so these are equal to 2. 4, 1 is equal to 4. That's interesting. Why are you so high? We are printing movement distance, right? So that's an anomaly. 4, 4 should be... Or 4, 0 is what it is. 4, 2, 4, 3, 4, 4. So it goes 4, 3, 4, 2 is equal to 2. So we go 4, 2 is equal to 2. 4, 1 is equal to 4 is what it's saying? It is. 4, 1 is equal to 4. So that shouldn't be how old am I? Yo, best of luck with the turn planner. See you later. I am 21. So we go here. Thanks for tuning in, Blue Mug. So we go like so. That's strange. And then 3, 8. Why is this so high? Why are you 5? Why is 3, 0, 5? What are we setting? Must be the distance function. It's gotta be the distance function, because the distance function goes What does the distance function set it equal to? The diff function sets all of it equal to movement minus diff. The difference is how far away it is, which normally should work fine, but then we should set it all equal to 0, I believe. Right? For x in range 11, for y in range 11. Bleh. Wait, so this is where we print. Oh, I'm printing it 2 times. What if I'm in the wrong spot? That is a silly mistake on my part. So we're actually going to pass this and then comment you out. That is a silly, silly mistake on my part. Unit 0011223344. Okay, we grab that. 44 should be equal to 3, 3, 2. Still, the bug persists, so it's 4 and it's 4. Is 3, 0, 4? 3, 0 is 5. Three, 2, 1, 0. And this one is 0, 1, 2, 3, 4. What a strange bug. So I need to see where movement distance is being changed like this. Oh, it's just me all alone. So sad. Whatever. I am sleepy. I should go on a run before it gets dark. Anyways. Where am I setting movement distance equal to something again? Must be in next tiles too. We set it equal to movement. Movement shouldn't be this large though. So I'm going to comment out this. Oh, hi, still here. Look at that. My watching now counter lies to me. So, how rude of it. So, let's see here. I'm going to comment out my second print statement and comment back in my original print statement. I hate how it autofills the second line. It makes it very difficult. I have no idea what you're doing, but trying to understand. That makes sense because I'm not really... You kind of only see me working on it in the process. I did go over a lot of it earlier, which would probably make a lot more sense. Right now, the general idea is I have these spacer variables, right, that I assign to each tile. I assign each tile a spacer variable of 1. And when my movement command accesses it, if it sees a spacer value of 1, it'll knock it down by 1. And if it doesn't see a spacer value, it'll keep it at its current level. And so by default, it always knocks the movement down by 1 when we recurse down from accessing it. I covered this earlier, probably like 10, 20 minutes ago, or like 10, 20 minutes into the live stream. That's kind of what I was showing over here. And this is me kind of demonstrating spacer values. So if you want to skip to like there in the live stream, that'll probably help you understand what I'm covering more. Right now, I'm getting some weird values. I'm trying to figure out why my roads aren't working. And I'm seeming to find the bug. Once we move out of traditional road space, we get these huge movement values, which should not be the case. So I'm going to go back here. Commented out the old one. I'm going to recomment in the current, or the former. We don't want spacer. We just want move distance. Just a real quick double check that move distance isn't being weird and buggy. We spawn on 4, 4, right? 0, 0, 1, 1, 2, 2, 3, 3, 4, 4. And we move. And if you want, I have all the code publicly available if you want to mess around it yourself. If you check the description here at the GitHub link, and you were to access it, you can find all the code that I'm working on right now. If you go to here, square grid, scripts, and tile.grid. This is slightly out of date. Actually, this is actually pretty out of date. This doesn't have roads, but it does have all the other movement that I'm working on. So if you want to check that out, feel free. It's all publicly available for you to access. If you run just like Godot, you can actually run the program yourself and make your own edits to it. If you ever want to contribute, I should plug the Discord, because I have a Discord for this project if people want to contribute anything to it. I'll just get a invite people. Copy link. I'm going to add this to the little description here. So there's the Discord link if you wanna contribute anything, and if you want to see the code, the GitHub will bring you there. So back to where I was. Let me try running. I think I already did run, but I'm just gonna run it again just in case I didn't. New run at 4. You shouldn't affect anything. I'm gonna run it anyways. I'm gonna relaunch it anyways, just because I don't want any unknown variables. So we're going to grab at 4, 4, right? 4, 4 is going to be equal to 4, I believe. 4. 4, 3 is equal to 4. 4, 2 is equal to 4. 4, 1 is equal to 4. 4, 0 is equal to 4. Why is everything equal to 4? You should not all be equal to 4. That hurts my head. So we're at 4, 4. This is equal to 4. This is equal to 4. This is equal to 4. You're equal to 4. You're equal to 4. But then this one's equal to 4, which should not be the case. Which means something is terribly wrong. Probably because I'm a terrible coder and I don't know what I'm doing. It's okay. So this must be done by tile.position, because it should all be set equal to 4, 2 at the very least should be equal to 3, and 4, 1 should be equal to 2. And it's not. And you're actually equal to 5, which means, yeah, something's terribly wrong. So we set move difference equal to movement minus the difference, which means the issue must be with difference, because this should access every single tile that we want to edit, right? It should never access the tile that we don't want to edit. And actually, I should probably change this print command to only work in the range of this. We're going to delete that, paste, get rid of this. That should only be, no, we have to multiply it by 2 again. Multiply by 2, multiply by 2. Oh, wrong thing. Multiply by 2. Okay, now I'm going to run it again. And now it should only be tiles that are being affected, which should make it a little bit easier to debug. Not much. Not much easier to debug. So 4, 4. 4, 5 is 3. 4, 3 is 4. 4, 2 is 4. That's terrible. That's not something I want to see. I don't... Something has gone terribly wrong in my code. Which means my move distance is wrong. So let's see what is movement distance doing exactly. I send it vector hold past, of which should be tiled up position. True. So it is sending it 4, 4 originally. And I can confirm this. Well, I don't need to confirm this. I know it's sending 4, 4. So I send it 4, 4. We take 4, 4. I want to be on you. So we take it in range of movement. Movement at this point should be 4 because it's 2 times 2. If I'm correct. Yeah, movement is, no, this is next tiles. Road tiles. Movement times 2. So movement is 2 times 2. Let's just check movement real quick. Movement's 2 times 2. It should be 4. So you run it. Well, it's 4. So we get 4, and we just times it by 2 plus 1. And that should access every single tile in the grid. But I'm going to write this down, right? So we have vector hold past. I'm going to need another matrix. God, I just need to do this one time and be quits. Call it quits. Like, just get it so like I can copy and paste it. I'm going to have layers here. Like ogres, sorry. Control C, Control V. I don't want to paste this for forever. Just going to flip this vertically. I didn't do anything. Flip it horizontally. That also didn't do anything. I'll just draw it vertically normally. If I'm smart, I do it on a separate layer so I can copy and paste it, which that's what I'm going to start to do. Draw 3 here. Control paste. Control paste. Anyways, this one's 0, 0. 1, 1, 2, 2, 3, 3, 4, 4. Call you 4, 4. 4, 4's movement distance is equal to. Well, actually, let me run this. Let me erase a bunch of this. The function we're running, wrong layer. The function I'm running is vector hold past plus our setting var equal that's way too large. Vector hold past is 4, 4. So you are equal to 4, comma 4. Vector 2i, xy, is equal to 2 times 2 plus 1. So 5, 5. It's a for loop from 5 to 5, and for loop start at. In Godot, start at 0 and go 0, 1, 2, 3, 4. And actually, I do want to. I've never actually checked this. I'm just going to print X. I'm going to comment out my other prints. So there should be some point in my code where it's just all one variable. So it goes from 0 to 1 to 2 to 3. Goes up to 8. Oh, wait, I think that does actually make sense because we pass it 4 and we take 4 times 4, which is 8, plus 1, which is 9. So yeah, it goes from 0 to 8. It stops. It's basically checking 9 times, which is, I believe that's correct, right? Because then what it's going to do, right, if you start at 0, you run 0 9 times as well. 1, 2, 3, 4, 5, 6, 7, 8, 9, right? We run each number 9 times equal to the number of for loops that we have, equal to the number of y that we have, essentially. So what we do is we access 0, 0 first, right? So, comma, plus 0, 0, minus movement, movement. Movement at this time is 4. Do I need to add to movement? Let's figure it out. So if this is, if 4, 4 is our base, right? At 0, 0, what we're accessing is 4, 4 minus 4, 4, which is 0, 0. This equals 0, 0. Which should be 3, 3, 2, 2, 1, 1. This is 0, 0. This is the tile we're accessing. Now let's see what we set this tile equal to. This is why, if you guys have been wondering why the Polytopia turn planner has been taking so long, you guys have been wondering why the Polytopia turn planner has been taking so long. This is why. I don't know what I'm doing, and I have to debug like this, and it's terrible, and it hurts my head. I have to run through all this math. I'm bad at math, guys. I had to learn all this stuff. Okay, so now we just go over here. We have xdiff is equal to vector hold x minus vector hold past. Vector hold past is tile. Vector hold x is 0, 0. So it's 0 minus x, which is -4, right? Because it's like the x of this and the x of this. So it's 0. We're going to go over here. 0 minus 4 equals -4. And then y is the same thing. It's 4. It's 0 minus 4 is -4. It'll see that both of them are smaller than 0 and set them equal to +4. It'll see that they're equivalent to each other and set diff equal to y diff. And it'll set so we set diff equal to 4. Diff is set equal to 4. Finally, now that diff is equal to 4, we can go movement, which is passed as 4, minus 4. It should 0, 0 should equal 4. Movement dist, vector hold, y, vector hold x, y, yeah. Movement dist is set equal to movement. Movement is 4 at the moment. Minus diff, which is 4 at the moment. Let me expand this out a little bit more. I love Paint. Paint is a great tool. diff is equal to 4, and so it goes 4 minus 4 is equal to 0. So move def on 0, 0 should be equal to 0. But move def on 0, 0 is equal to 8. Which is wrong. You should be 0. What are you wrong? I don't know what's happening. I guess we just run through the rest of the function. Okay, well this is wrong as well. So let's fix this first of all. Because you actually need to be this movement function. Correct? I believe correct. I should set spacers correctly. This is row tiles 2. Am I running row tiles instead of row tiles 2? That would really irk me. No, I'm running row tiles 2. Tile spacer set equal to 0. Position, movement distance. Movement distance should be equal to 0. We're not running any more print statements, are we? We aren't. Let me just run it again. Please work. 0, 0, 1, 1, 2, 2, 3, 3, 4, 4. Print. 0, 0, please equal 0. Equals 8. Ugh, my poor head. You're blowing up my poor head. Why would it equal 8? I don't know. Let's go back into road tiles 2, I guess. It's 2 times 2, which is 4. We're not changing movement anywhere else, are we? No. Let me just print movement. Make sure movement's entering as 2. And I'm also going to print a string movement. Shabap, shabu. 0, 0, 1, 1, 2, 2, 3, 3, 4, 4. Run. Movement. Okay, wait, I forgot. That's not a good way to do it. Whatever. Scroll up to the top of here. I think it should be just after this, but it's not. Okay. Movement's equal to 2. So we are passing it 2. And 2 times 2 is 4 plus 1 is 5. 2 times 2, 4 plus 1 is, well, it's 4, so. Oh, this is not in road tiles. So it's 2 times 2 is 4 plus 1 is 5 So we have vector hold, which is 4, 4, plus 0, 0, minus 4, 4. Why is it? Why are you lying to me? It's obviously not lying to me because the code's always correct, but ugh. Vector hold Then we just got to print vector hold. Now I actually want to comment out what's printing all these. Yeah, I need to comment out this X here. Nope. No, you're incorrect. Okay. Print it again. Unit 0011223344. Play. All the way to the top. Vector hold 0011223344. I should have been doing this a long time ago. Okay, so that gives me. So it's accessing all the tiles, if I'm correct, right? It is accessing 0, 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, 0, 6, 0, 7, 0, 8. Stops at 8, right? We're not getting further than 8. It should go all the way down to 0, 1, 2, 3, 4. 1, 2, 3, 4. That doesn't help. 0, 1, 2, 3, 4, 5, 6, 7, 8. Should go down to 8. It stops at 8. That's good. But then are we setting movement distance equal to anything in the roads? Shouldn't be. So I guess the issue must be this right here should be 8 if I print it. Zero zero one one two two three three four four. Boom. Okay, so it is 8, which just means my math's wrong. Thank God. How can it be wrong though? So we have 4. 4 minus diff. Well, what's diff? We're going to print diff, and we're going to comment out movement distance. 0, 1, 1, 2, 2, 3, 3, 4, 4. X diff is negative 4. Or diff is negative 4. If diff is less than 0, X diff is set equal to negative 1. If Y diff is greater than 0, Y diff is less than 0, right? If Y diff is equal to... Okay, so where are we going wrong here? How is diff equal to negative? Else, if Y diff is greater than X diff, diff is set equal to Y diff. Okay, so you guys clearly aren't being converted back from negatives, which you should be. So we're going to print X diff. We're going to print Y diff. We're going to get rid of the original Just gotta remember it goes x and y. Both of these should be positives. 0, 0, 1, 1, 2, 2, 3, 3, 4, 4. Hopefully you're positives. You're both negatives. Why aren't you catching these? You have one job. Huh. I just could not fathom these if statements failing. I guess we can take absolute value of oh, I know what the issue is. I'm not setting xdef equal to xdef times -1. Oh my god. Oh my god. How could I forget that? How could I forget that? This caused me so much trouble. It's just this tiny little mistake. And I'm not even setting diff equal to ydef. Wait, no, I am setting diff equal to ydef. How could I miss that? How could I miss that? Okay. That should have fixed it. Oh my god. I can't believe I did that. That's so silly. That costed me so much time. It's the simplest little thing. I just forgot to set it equal to 0, 1, 2, 3, 4. Go. If it's broken now, I'm ending the live stream. It's 0. Thank God. That caused me so much pain. Okay, it's 0. Thank God. Oh my God. Oh my God. That costed me so much trouble. Now 1, 1 should be equal to 1. 1, 1 is equal to 1. 2, 2 should be equal to 3. I mean 2. Yeah. 3, 3 should be equal to 3. 4, 4 should be equal to 4. 3, I don't really care. 4, 4 is equal to 4. 4, 3 is equal to 4. And now I'm seeing why my code fails. It's because 4, 3 exists. Ooh. I didn't consider that. Yeah, because it tries to prioritize the larger number away. Huh. If it's 0, 0, right, the xdiff is going to be equal to... It's going to be equal to vector hold x minus vector hold x. That's going to be equal to vector hold y minus vector hold y. So if it's 4, 3, instead of 4, 4, we have vector hold x minus vector hold x, which will give us 0. And then we have 1. And then 1 is greater. Shouldn't 1 be greater than... ydef is 1, xdef is 0. ydef is greater than xdef, diff is set equal to ydef. Else diff is set equal to xdiff. So shouldn't 4, 3 be set equal to... Because diff is going to be equal to 1. Ydif is greater than xdiff, which fdiff is equal to 0. Movement minus diff, which should be 1, so it become 4, and then it become 3. So I'm not out of... 4, 4 is 4. 4, 5 is 3. Which is concerning, because if y, it's 5 minus, because it flips the negatives, because it's 5 minus 4 becomes 1. But if it's 3 minus 4, it should still become -1. And then YDEF, if YDEF is less than 0, it's because I didn't set YDEF equal. It's because I set YDEF multiplied. I did the same mistake again, back to back, after it already cost me an hour of progress. Are you kidding me? This is crazy. 0, 0, 1, 1, 2, 2, 3, 3, 4, 4. Oh my god. Oh my god. 4, 3 is 3. It works. It works. It works. I'm so happy. It works. We should never have anything greater. I'm so happy. I'm so happy. Can you hear the pain in my voice? Oh, I've worked so long on this. 5, 3 is 3. 5, 4 is 3. 5, 5 is 3. It works. It works. 5, 6 is 2. 5, 7 is 1. 5, 8 is 0, 0, 0. I'm so happy. 5, 7. 5, 8. And that goes to 6. I'm so happy. I'm so happy. Is anybody here to witness my triumph? Oh, this thing isn't live. Is anybody here to witness my triumph? Yes, that one guy is. I'm so happy. Oh, it's just me now. Let's go. Anyways. Back to it. Slap fixes that. I can't believe I messed that up so bad. Anyways. We now have our movement diff. Now. How could I have messed up this? I'm not sure. 0, 0. So I should see that the x diff so the highest x diff is 4, which is the vector hold original. Oh. Oh. Wait. Should still work. So if it's movement dist by 2 plus 1, movement dist by 2, it's already at 4, so it becomes 8 plus 1, which is 9. And we start at 0, 0. Let me try testing out spacers, I suppose? No? Let me try spacers. Zero, 0, 1, 1, 2, 2, 3, 3, 4, 4. 4, 4 should not have a spacer. Correct. 3, 3 should not have a spacer. Correct. 2, 2 should not have a spacer. Correct. 1, 1 should not have a spacer. Correct. Everything else. Okay, why is it printing me 2 variables? What is... Oh. Okay, top one's spacer, bottom one's not. 0. Everything else should have a spacer, though. Correct. Awesome. Which leads me to believe that tiles without spacers are overlapping tiles with spacers, which is an easy fix Hooray! An easy solution. Ah, ah. I just need to write an or statement here. Or no, it's not an easy fix. It's never an easy fix because it hates me. It's okay. What if I just set spacers equal to -1 by default? I think that would also work. So we're going to try that. We're going to go or if tile.vectorHold has a spacer. There's a better way to write this. Like an else if. Whatever. I just want a sloppy solution so that I can be free. Or if tiles dot x dot y spacer dot spacer is equivalent to 0. And now I'm just going to go over to tile real quick and set spacers equal to -1 by default. Zero, zero, 1, 1, 2, 2, 3, 3, 4, 4. That's progress. That's progress. That's progress. That's progress that wasn't there earlier. Yay! Oh Lord. That's actually correct. You aren't correct because you can go 1, 2. You for sure aren't correct. You are correct though. Well, no, you're not because it should be able to go out more. Which is interesting. This is progress. I am really happy that I'm making progress on this. Because you're on 3, 3, 4, 4, still have the road bonus, then you go out more. Indubitably. And if you're off it, right, you can move onto the road tile and move 1 further deep. That's progress! I'm so happy. I could try to push this farther. I bet I could get roads done if I put another 2-3 hours into it. But I choose life. I wanna eat dinner and have a nice night. So yeah, maybe go on a run too. So I'll probably try to get roads done tomorrow. No, I have a lot of work to do tomorrow. No, roads will get done sooner or later. Roads will get done eventually. Thank you to the 4 or 5 people who tuned in today. I'm glad I can talk about my madness to somebody else. Because I was going a little crazy. Yeah. If you're watching this post right now, I hope you enjoyed. If you learned anything, that makes me very happy. That's why I'm posting these. Have a good one, everybody. Here's